Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Well, welcome to the latest episode of Lunch with Tech Leaders. My name is Ray Welker. I'm a cloud solutions architect with Right Brain Networks, and I'm going to be your host today. Joining me is Adam Oberhausen, as well as our co-host, software and data consultant, Tom Kowalski.
Hi, Ray.
And in this episode, we're going to discuss some core strategies and share some best practices for implementing infrastructure as code. So we got a packed agenda, lots to talk about today, so grab your lunch, maybe a notepad, and buckle up.
Do it.
Yeah.
All right.
So infrastructure as code, right? You know, I think we're all have had some hands-on experience with it at this point. Been around for quite a while. It's really the management and provisioning of infrastructure through code and automation scripts rather than, manual definition of it. Pretty much supported across all the various clouds now. Even Alibaba, I think you can have a you can have a provider for that, and you can write Terraform for it. Primarily, we work with AWS, Azure, GCP. There's some cloud native tools that, like infrastructure as code tools like CloudFormation and CDK, that are a little bit more native to AWS, even though you can do Terraform CDK nowadays. It can span across multiple clouds. But I think a lot of the best practices, I think that we've just kind of found over the years and, through research and whatnot, kind of apply to all the tools regardless of what you write. So main things we're going to focus on, I think, would be Terraform, CloudFormation, and primarily, AWS, the cloud, for being the source there. But I guess overall, do you guys recognize some of the core benefits of infrastructure as code?
I'm intrigued by, saying automation scripts, and kind of where do you draw the line, or do you differentiate between infrastructure as code where you're kind of, setting the state of where you want to be versus, running a script, right? It's almost borderline manual. Yeah.
I would say, yeah, automation scripts are probably a little outside of infrastructure as code, mostly because it's, working with the API and or the, just the CLI, which interfaces with the API in order to, provision something in your cloud. So I would say that is provisioning infrastructure through scripting is probably not something I would consider infrastructure as code, but maybe using automation scripts in terms of like testing can still be, as well as like, security and vulnerability finding within your infrastructure as code could be a component of that. There's a lot of open source tooling, which I would consider, there's scripts in general to test your code for vulnerabilities, sanity checking against, resource guidelines like for AWS, kind of just do some validation and whatnot. I would kind of consider that more so still a component of IAC and just a way to maybe produce better code. That's kind of my thought.
Usually fill in the gaps. It's kind of how
exactly.
Notice if there's some type of script or whatever in there.
Circling back to your question, Ray, which was like some of the maybe the core benefits of infrastructure as code, and there's a ton. I'm sure you've got a list that you're going to rattle off, but when I think about coming from a developer background, your code that you write goes into a repository that is version controlled, and you can track all that history and changes of everything you did. Infrastructure is in a different spot. Like you couldn't write code without writing code, right? So with infrastructure, you can do infrastructure without writing code. So organizations have that option to bypass infrastructure as code. I've seen lots of companies don't have infrastructure as code. So what you end up is having, those knowledge silos of people who, have built the infrastructure by hand, or maybe could be configuration drift in all these environments. So I think from just an organizational perspective, like you just have to infrastructure as code is like table stakes. I feel like you have to do it in terms of like just being a successful, mature software company. Like you should have infrastructure as code so that you can create repeatable environments, avoid configuration drift, and understand how things are configured in general. So that would be
I think you touched on a big one there, which is that auditability aspect of it. You're following some sort of Git flow at this point, so it just makes sense by having remote repositories as well as some form of version controlling. Like that just increases visibility into any changes that happen with the infrastructure. So, I mean, kind of adopting that approach and version controlling your infrastructure as code as well is a very valuable process, especially if you get into a position where commit some bad code. You have prior commits you can revert back to. Cherry pick out maybe the necessary code and revert some of the revert whatever breaking changes may have been implemented. But it just kind of it's a lot more I think today now following SDLC processes with infrastructure as code as well is a general best practice. Trying to shift that further left and get more visibility early on with your infrastructure and prevent breaking changes happening later in the process. But yeah, your need for like the comment as well with scalability, it's huge. I mean, like you can produce repeatable code that you can also scale your code at that level as well. If you want to deploy out to multiple environments, for example, you can reuse the same patterns, the same code, and deploy that out as needed, and just overall saving overall ops time, I would say.
Yeah, it kind of allows you to, one of the mantras I always tried to stick to is like your operations and infrastructure should always be ahead of the development needs. You don't want they should all be working together with collaboration and all that, but like you don't want your lack of infrastructure as code to be a bottleneck if your delivery team's trying to build something new or scale out something. Much better to be able to modify some infrastructure as code versus like pushing a bunch of buttons and pulling levers in the AWS console, right? So
you need to be careful too, right? Adam, you threw out, right? Like, you should be doing, or you need to be doing it as a modern software development organization. I think you just need to be careful with that and how it gets implemented. Obviously anything new that you're doing and a new solution, yes, it's a no-brainer. You should be using infrastructure as code. Where I see the problem is existing applications, and if your organization isn't quite set up to handle that, maybe you do have those silos of operations and devs, and you think, oh, we have to do infrastructure as code, and you might have an operations team that's working on it over here, and it's still separated out, and you're going to run into problems with that. So it's okay to have the operations owning it, working on it, but I can always say it needs to flow up to one team, right? Or one person that kind of owns that application holistically and can make those decisions across the infrastructure and development. So yeah, I just have to say that out there, caution, right? It's usually the tools can be implemented and be great, but you have to have that organizational structure to be able to handle it. Sometimes the tools can lead and the organizational structure follows it. But yeah, other times it's hard, right? And you get into that where they clash. So just be aware of that, right? Whenever you hear, you got to be doing this or that, or it's always, it depends. It is a great thing, but you got to be.
I think that's really interesting what you said. You see that so often, right? You see, kind of the tool trying to lead the way, but there's no overall strategy. And when you have existing applications and maybe an approach where, we're trying to buy into this infrastructure as code idea, but it's kind of like ad hoc and each team's doing their own thing. It doesn't really, that can cause problems, I feel like, kind of as a more of an organizational, like, it's a business issue at that point, or at least an organizational problem at that point, because you don't really have any I say global direction, I would say, from the organization of how you should be implementing IAC. And that can, lead to problems as you're trying to maybe, share information across teams at a later point. Like I always feel like, it's a good practice to try to break down those silos, those knowledge centers, and share information across the organization, or at least write and follow practices that are standard across your different teams. And if you don't do that, hopefully you're following some other things like, good documentation or something like that so you can get people up to speed. I think having a good strategy in place is more important than actually just, hey, we're going to use this tool now. You should have a plan to it. And I think we can talk about what a good plan looks like here today. There's a big thing that we talked about here, and I think it kind of transitions well, which is structure overall of your infrastructure, of your infrastructure as code. Should that be coupled with the application, or should you separate that? Should you have a mono repo, or should you have a macro repo, or something like that? Those are always decisions I feel like that kind of need to be talked about quite a bit before just making that approach. Because once you kind of start it, it's hard to walk away and decouple it at a later point if you make a change.
I've always teamed everything in the repo, right? But this again, right, is if you're doing something new, I highly recommend everything from the pipeline, tests, your infrastructure as code, the application code, business logic, all of it, right? For that workload should be in the same repo.
I'm in the same camp as you, Tom. Yeah.
I think it helps people that contribute to the repo in whatever capacity it is, like having everything in that repo with the proper documentation in the repo is preferable too, with readmes and whatnot, versus having to go to an external source like a Jira. That, in my experience, is my preference. I've seen it both ways, where you have the infrastructure repos in a separate spot, and it can work. And it makes sense for some things. I think we recently did some work with a client. They kind of have this spread out, all these apps spread out, distributed amongst repos and global teams. And, we needed to provide an automation solution that was going to impact all these apps. And so we could either repeat the code in each repo, or we could create one repo that centralizes this automation, because it's basically doing the same thing for all these different applications. So, I think there's always use cases where it makes sense to break things out, but in general, my rule of thumb is the closer you can keep it to the source code is better.
Yeah, I think that's a very good point. There are situations where perhaps they are more of a global, a global repo. It doesn't need to be within the application code itself, but it's kind of a more, I don't know. There's use cases for both. Generally, I if it's related to the application, your infrastructure as code should be there as well. There's pros and cons to either approach. I think the biggest drawbacks of having that so tightly coupled to your code is more so access control related. It's a little harder to control direct access to the application and its source code than if things were separated out. So ops may have same permissions as dev. Generally, there's ops is generally probably not touching the application code itself. So in itself, it's kind of safe, but it can also make it a little bit more robust to read. It can become a little bit more complex.
Just to touch on that, right? It could make it harder, but once you have the systems in place and good ops and permissions, it actually becomes easier, right? If you can standardize that, really get your process down, and then also on the compliance side, there's some may say, oh well, we can't do that, right? Compliance, I've seen it, all of the SOC 2, PCI, the higher level ones, you can do that, right? There's mitigations and controls that you can put in place where you can have your infrastructure and code in the same repo, and there's no quote me, right? To your auditors may say different, but there's ways around it.
To quote Tommy from a previous episode, it depends, I think. So I'd say even more to maybe touch on some other best practices is separating out your files into it just to make them more readable. Take Terraform, for example. You have a place where you can declare your variables, a place where you get a file, you can declare your outputs. And then, for example, you maybe have, your main where your actual resource definitions live. I think overall, just kind of separating out your, just having a good overall file structure for your infrastructure as code makes sense. Same for CloudFormation. Perhaps we have folders directly related to some component for a stack I'm deploying. So perhaps take an example would be like, if I'm trying to deploy like a self-hosted GitLab, for example, within I would say my mono repo, all of my infrastructure is code. If it's maybe like going into a shared services out, I might have like a GitLab folder in there for a GitLab related CloudFormation stack that has all the necessary security groups, maybe the ECS cluster, if it's living within its own, task definition, pretty much any component in there, I guess, properly defined within its own subfile. So like having a VPC dot TF or a VPC dot, security groups dot, TF or JSON or YAML if I'm writing CloudFormation, for example. But just kind of separating out those resources into logical groupings, I think just makes adoption of anybody else coming into that code base to be able to pick it up a lot easier. I think that kind of gets into the readability aspect of defining your infrastructure as code. It's it should be self-declarative. If things are structured well and your resources are named well, it should be able to document itself, and you should be able to just look at it without needing to read a README. But that in itself is a good thing, I think. To have that coupled with it as some sort of external documentation to the code. But yeah, I think like that's a good standard practice for whatever IAC you write. Just having some good, well-defined names for your various files.
Following up on that, Ray, how do you make sure that your infrastructure as code is reusable, right? You could have the situation where you have like 6 environments and they're all, they should be all identical. Is it the best practice to like copy that VPC file into each folder for each environment, or is there some ways to share, kind of following the DRY principle, don't repeat yourself? Is there ways to do that with infrastructure as code?
That's using, there definitely is. And yeah, creating reusable code, I think, is a very good standard best practice. Don't really need to duplicate yourself. And that's pretty much just having parameterized names for both resources as well as your values you're passing into your resources, so that you can say like create a top level stack that passes in the various values to say Hello World ECS app or something like that. I might be able to copy that same stack, pass in different parameters and create a Hello World 2 app or something like that. Or maybe this is my actual functioning prod app. So keeping names well described, I would say. So kind of, passing in what we like to do at RBN at least is, have a service parameter, have a environment parameter, maybe an organization/account parameter. And then sometimes it can get a little bit more specific to like product as well, possibly. So those are, a couple top level values that might change, but you could still reuse the underlying code because I'm still creating, an ECS cluster or an ECS task definition and a security group. So parameterizing it as much as possible and, just changing the values when you actually call that stack, I think are the best approach to reusing some of that code.
Yeah, and as you were talking there, I couldn't help but think about the ability to make sure your resources are properly tagged using infrastructure as code. I mean, huge win. Gives you that granularity from a cost optimization. You can specify an owner tag so you know exactly who owns the resource. So I think just, a big benefit, circling back to some of the core benefits of infrastructure as code, is just like your ability to tag every resource and make sure that you have consistent tagging across everything you're doing in any of the cloud environments you're building is a great way. I think it's really easy to say that's not important to do, or, it's not a priority because we're growing and spend is not an issue, but then all of a sudden it is an issue, and it's so easy to set it up from the get-go using your infrastructure as code. So
yeah, I feel like there should always be a 101 class to standardizing and best practices for your AWS cloud or any cloud, that you're trying to adopt, because it's a lot easier to set things up when you first get started than it is to readjust things later on. And this is AWS specific in this case, but like to your point around tagging, enforcing that at organizational level, I think is a great idea in theory. With prod, it may not be in existing accounts. It may not be one in practice until, you maybe get a little bit further along. Things are rectified prior to enabling that. But at least, yeah, you get visibility into where your resources are in AWS and, what's contributing to spend. And there's just so much you can do with tags. I mean, you can do automations based tags as well, which is, you can include them as a part of some sort of, automated workflow.
Mm-hmm.
I think a big thing we were doing now was, based on a scheduler, trying to schedule for a client, some start and stop.
Mm-hmm.
And that can be, there's a million different ways you could do that. Not a million, but a few different ways you could do that. But, having well-defined tags ensures that, we're targeting the proper product and the proper resource. So we don't have any drift, and there's no risk associated with other products. And that's where it comes into clear naming of resources as well. That's kind of that tagging approach and the parameterized approach I'm talking about with some of the variables that you pass in. Proper naming of your resources so you can quickly identify if you need to go into the console, what something belongs to goes a long way.
Yeah, there's a great video I watched about naming conventions by Robert Martin under his clean code video series, where just there's a 44-minute episode on just naming, right, and descriptive names, and it applies to your infrastructure as code as well. So it's a good watch. I worked with Tom for many years. Naming was often the source of many critical decisions, right? I mean, it's just like you get hung up on a naming convention and you have to stick with it, and it needs to be meaningful. It needs to make sense. It needs to, you shouldn't be writing a comment to explain why something is named the way it is. So there's a lot of thought that goes into naming, and almost everything people in our line of work do. So
yeah, a quick question that we would ask is, would you be embarrassed by this name in 5-10 years looking at this code, right? And it makes you, step back and think about it, like, yeah, maybe it should be named differently.
Yeah, I guess another key aspect of you could talk about is like, how do you guys handle secrets in codes? Like, what are some things that you've found that work? Both in, say, app development as well as infrastructure as code.
Well, I really like the secrets manager tools out there in the cloud services. I've worked with GCP's secret manager and also AWS's, and it's just really easy to use. Definitely want to avoid hard coding your secrets in your code. Things like your API keys, database credentials. There's services that store these now in the cloud for you that are dirt cheap. They can even do, most of them provide like automated rotation of keys. I haven't worked with that too much. Yeah, I mean, and it's just like you said earlier, there's a million ways to skin a cat here. What I just threw out are some of the managed services, but I've even seen just encrypting a file in S3 that you download and decrypt, and it sets your environment variables on your instance. Like there's many ways to solve this problem, but the best practice is to just avoid putting your secrets in your code directly, because it's a big no-no and can lead to some really bad outcomes and some challenging postmortems.
Definitely agree with that, and I feel like it's not as commonplace to actually see like hard-coded secrets nowadays. I feel like a lot of people are kind of following the practice to some degree. What are we going to actually like? What are we going to store, and what are we actually going to consider like a secret? Yeah, like API keys, passwords, so forth. Leveraging all the managed services are definitely what I'd recommend. And I think you brought up an interesting point about like setting environment variables in a way that's like kind of like an automated script prior to like doing some form of deployment, or even like, ensuring that that's encrypted, I think is that's definitely a great practice. You want to ensure it's encrypted at rest as well as in transit if possible.
So I haven't worked a ton in Terraform. I've done, like I mentioned earlier, Ray, a lot of labs, a lot of online learnings, but like, how does Terraform, I think I may say CloudFormation, how do you reference a secret in AWS Secrets Manager in your template? Is it just like a built-in thing, or like how do you actually?
Source. Yeah, there's a data source within Terraform that you would call, there's like AWS and of course secrets manager data source. You pass in the secret name and it writes that object as the secret type essentially, and it knows how to handle it for, if I'm working with AWS, for example.
It's like the role that is executing that infrastructure as code needs to be able to access that secret, right? So that it can reference it and grab it and, put it in your template and do the magic. Is that how that works?
You can define your role in your provider block as well for Terraform. So you're effectively the role that you are assuming when you go to do like a Terraform plan, you can tell it to assume a role within your, like, say, AWS provider. And that role that, is being assumed could have access to the underlying secret. So like you directly as user Adam Oberhausen, or perhaps like a role like an AWS delegated administrator or something that you guys set up, doesn't itself need to explicitly have access to the secret, but the role that you can assume to do infrastructure's code deployments would have access then in that case. But yeah, that's another good point as well, because I mean, you want to apply a least privilege, I'd say, approach to how you grant access or for your ops / your dev team as well. And in that case, there's a more of like a build user or something, like a build role that can be assumed. That build role could be specific to, say, like an environment. So perhaps, I have a stage build role. Maybe that stage build role only has access to stage resources, so you don't have, drift into prod, for example. If you're, within the same account or something like that. So there's a way you can, better strategize how you grant access, as I think the underlying thing there. And the other fun bit with Terraform is that there is a state file. That state file, you need a backing state management. So you can store state locally, which is not a recommended approach if, you're working in a multi-member capacity. So you'll have to leverage some form of shared state repository like S3 or perhaps like Terraform Cloud. There's a couple different ways you store your remote state file so multiple people can do a deployment, but that state file can contain sensitive data. So you want to ensure in that case that, however you store that state file, it's encrypted, and it remains encrypted in transit as well is a good practice. Terraform Cloud by default, it's encrypted. If you utilize S3, you can set encrypted on, set the object as being encrypted, leverage the S3 backed encryption, or you can use your own KMS case.
I think it really depends on the architecture, right? What you're building on, EC2s, containers, or serverless, right? It's going to depend on how you do your credentials and secrets and how they get injected, and how the infrastructure code plays with that. Something that I've been leaning towards more is kind of not having any credentials, right? Just leveraging that role, and then any credentials you need, pulling them at runtime. So sometimes you can do that, sometimes you can't, right? It depends on your architecture. And with serverless, that's now adding to calls that it has to make, in your cold start to grab those credentials. But it's just easier, cleaner that way, right? You kind of want your app to be pulling credentials anyway, right? If you're rotating them, you want to be able to update those and have your app just have a cache, and it's pulling the latest every 5 minutes or whatever behind the scenes every hour. Yeah, versus having to put it in your infrastructure as code. So if you can, right, that's what I've been doing, like latest project.
That's a very good approach, actually, and that's something I was working with a client, and we're trying to get into that state. So it wasn't an original offering, and what we were doing is we were sending a random generated string for like an RDS master password, as well as a read-only user within the database. The code at the time was not equipped to say, like, if you were to try to connect using the credentials that were provided to try to fetch them again from the provided secret. And I know AWS now offers part of the SDK, you can actually rotate the RDS password itself. So I was working with them so they could update the application logic to say, if we fail to authenticate and connect to the database, let's try to grab the secret again from Secrets Manager. So it wasn't something that they were polling every so often. It was essentially pull it until it fails, or well, keep it cached until it fails. Once it fails, we'll try to pull again. But this allowed for us to implement like automated rotation of RDS passwords, which is just a good security best practice, I think, in general. Really, it minimizes downtime because connections that are already, being made to the database stay active until they're dropped. And, at that point, there's minimal user experience disruption, I guess, in that case. So definitely a step in the right direction in what they took there. I'd say the other thing, just real quick, I know we're coming up on time here. Speaking about credentials, you can define outputs as well. Outputs can also contain sensitive data, so you may need to be selective with what exactly you should expose as an output whenever you do a deployment. Things such as like certain IDs or keys, those are something you wouldn't want to output, or maybe like whatever a generated password would be. You may not want to output that in clear text, largely because these are going to be visible within the state file. There are a couple tools as well that we kind of briefly mentioned early on, but I don't think we named. There's a lot of good practices around handling like testing and validation. Some cool things that I had found here just prior to the podcast here today, and these are all open source tools. CloudFormation, there's some testing tools such as CFN Lint. That is a static code analysis for CloudFormation in a way to essentially just validate the YAML or JSON templates against CloudFormation resource specifications. Definitely start that repo. I think something I'm going to try here at a later point here this week. Just see if we find anything that maybe like wasn't properly done or something like that according to best practices. CFN NAG looks for security vulnerabilities within your infrastructure. There's another one related to Terraform, such as like TerraTest, which is an open source Go library for testing infrastructure. So a couple of neat tools out there on the open source front, community-backed tools that I think could be, they were new to me, and I would love to see if they provide you. Cool. With that in mind, we are towards the 30-minute mark here, and I just wanted to say, thanks to all of our listeners out there for joining us. We hope you found this informative. Next week, we will be having Lance Carlson host an episode on programming with ChatGPT and going over the chain of thought methods for programming with ChatGPT. Definitely look forward to that episode. I'm sure we'll feature some expert guests and have some valuable conversation.